In this section, we're going to be talking about proving triangles similar. So you want to remember similarity is different from congruent because similarity just means same shape but doesn't have to be the same size. Okay? So we're going to have three reasons for similarity, and a couple of them are going to sound very similar to our congruence reasons. So you want to make sure you're looking carefully at what makes the reason work. So the first is angle-angle similarity, and it states exactly what we need to know. Basically, two angles of our triangles need to be congruent, then we got similar triangles. Alright, so let's go ahead and write that down, right? If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Taking a look at these triangles that I've sketched out in red, we've got triangle ABC and XYZ. So again, as long as we know two angles are congruent to each other, then the triangles are similar. So for example, if we know angle A is congruent to angle Z, right? And angle B is congruent to angle Y, then we can say that triangle ABC is similar to triangle XYZ. Remember, that's the symbol for similarity. And that works because, again, as long as the angles are all the same in your triangle, the sides are all going to be proportional. And we know angle C and angle X would be congruent by your third angle theorem. That's why we only need two angles and not three. Okay? So take a look at example 1. Think about this. Let's go ahead and name these triangles. Here we can call it A, B, C, D, E. I want you to tell me why the triangles are similar. So tell me what reasons make it similar, and then write the similarity statement. So take a moment and think about it, right? Obviously, we've only talked about one, so we need to know two angles are congruent. Which two are they? Well, clearly from the given, angle A is congruent to angle D because that was given to us. And then we can also see, what do you know about angles BCA and DCE? All right, and you'll see BCA here in yellow and DCE there in the purple. Those are our vertical angles, so we know that angle BCA is congruent to angle DCE because they're vertical angles. All right, and then we can say that triangle ABC is similar to triangle, let me clear that up a little. Okay, let's try that again. So triangle ABC is similar to triangle DCE by angle-angle similarity. Right? So in that type of problem, I want you to tell me what you know, right, and what's going to prove the triangle is similar. So if you just told me ABC and DCE are similar, that's not enough. You're going to have to tell me why. Okay? Next up, we have a side angle side similarity. So let's see what that says. All right, so this one says if two sides of one triangle are proportional to two sides of another triangle, then the included angles are congruent. Oh, and the included angles are congruent, sorry. Then the triangles are similar. So notice again, similarity talks about proportionality. So we don't need the two sides to be congruent, we need them to be proportional. So for example, if you take a look at these two triangles down here, ABC and XYZ, if I knew, for example, AB and its corresponding side ZY, that ratio is equal to BC and its corresponding side YX, that's proportional, right? So those are two pairs of sides that are proportional. Then we need to know that the included angles are congruent. So we need to look at the angles that are sandwiched between those two pairs of proportional sides. So that would be angle B and angle Y. Okay? So if we knew that angle B is congruent to angle Y, then we would be able to say altogether that triangle ABC is similar to triangle ZYX. And just to make this really clear with this proportional bit, you need to show me that the ratios are equal. So for example, if AB was 9 and YZ was 18 and BC was 6 and XY is 12, they both reduce down to 1 over 2 or 2 over 1. That would make it proportional. Okay? Last one is side-side-side similarity. And this one says, if all three corresponding sides of two triangles are proportional, then the two triangles are similar. So you want to make sure all three are going to end up with your same ratio. So for example here, if AB corresponds to, let's say, XY, that would make those two sides proportional. And then if BC corresponds to YZ, and that ratio equals the first, that's proportional, right? And finally, the last two sides, AC and XZ, they ought to have the same ratio as well. If these three things were true, then we would be able to say that triangle ABC is similar to triangle XYZ by side-side-side similarity. Make sure you have your ratios lined up correctly. So see how I put the small triangle on top and the larger triangle on the bottom? I stayed consistent. You want to make sure you do that. Every year I do see people kind of mix it up, and then they'll say, wait, why do I have reciprocals? And that's usually why. And to make this really clear, you can see some numbers. So for example, if AB is 7, BC is 6, and AC is 8, then and XY is, let's say, 21, YZ is 18, and AC is 24. If I plug those into these three fractions, I would get the ratio of 1 to 3, right? And then I'd get 1 to 3, 1 to 3, 1 to 3 for all three of them. And that's how side-side-side works. So we're looking at those ratios, remember, not congruent, because we want similar. They can be bigger, smaller than the other, but they just have to maintain the same proportions. Okay? Let's take a look at example 2. I want to point out something here. Remember to look at the directions carefully. I want you to verify the triangles are similar. That means they are similar. So tell me how you know, right? So you're going to use AA, SAS, or SSS, and you're going to tell me from the diagrams or from the work how you know they are similar. Okay? So here, hopefully it's pretty clear. We've got two sides and an angle, and those angles are in between your sides. So we're probably going to use SAS similarity here. So that's something I want to use. Then I want to pull out the three pieces of information that make SAS work. So obviously those included angles, angle D is congruent to angle H. Give me the reason why. That was given. Right? So basically write a proof. And then I want to say, well, are the sides proportional? It doesn't matter which you go with, right? Large to small or small to large. Just be consistent. So I'm going to look at DE over its corresponding side, HJ. And let's see what we get. So that's going to give me 2 over 1. Don't reduce it because I want to look at my ratios. Then I have the other two sides. Let's look at those corresponding sides. Again, I'm going large to small, so DF over HK. I want that to also equal 2 to 1, and let's see if that works. So I'm going to get 5.8 over 2.9. Remember, if you want to get rid of those decimal points, basically multiply each of those numbers, the top and the bottom, the numerator and denominator, by 10, and that gets me 58 over 29, which then I can reduce down to 2 over 1, right? So this tells me DE over HJ is equal to DF over HK. So I have two sides that are proportional, and the included angles are congruent because that was given to me. So this is enough work to say that triangle DEF is similar to triangle HJK by SAS similarity. Okay? Go ahead and try B and tell me what you get. So check your work. Remember, you want to show me all three ratios. So show me they all reduced down, and hopefully they got to be the same fraction. So remember, it's okay if you got 3 over 2. If you went large to small, you'd get 3 over 2. Oops. I accidentally hit that corner, minimize that. Sorry about that. So again, we want to check that you've got the same ratio. So if you went large to small, you get 3 over 2. I went small to large, so I got 2 over 3. What's the most important here is that all three sides are proportional, right? Clearly, I don't know anything about the angles, so don't assume anything. And then I can use SSS similarity here. So triangle PQR is similar to triangle STU by SSS similarity. Okay? Make sure you're not using the wrong symbol. We want similar, not congruent. For this one, you could have also used side, angle, side, but you'd want to show me we have an isosceles triangle, so we've got congruent base angles, or you could use but nope, let me take that back. You might think that, but we don't know that those angles are actually the same. So that was a good point to point out. But so you want to make sure you don't get into that trap. Okay, finally, we've got a proof. So now we're going to show that the two triangles are similar using either SAS, AA, or SSS. I always encourage you guys to look at the given and look at the diagram. The diagram might be the most important here because you should be able to see an unmarked congruence. Do you see an unmarked angle pair that are congruent or sides? Hopefully you guys are seeing the vertical angles right here. So because we've got congruent vertical angles, we probably want to use SAS or AA. But here I don't have any parallel lines or anything to give me another angle, so I'm going to go for SAS because I'm also given information about two different sides. So let's see how we can make SAS work here. So let's write in our statements and reasons. You can always start with your given. And 3VT is equal to 5ST. What we want to do here with these two equations is we want to create proportions that show that the two corresponding sides are proportional. So look at UT and RT. So that is basically one pair of corresponding sides. So in my notes here on the side, I'm just doing my brainstorm. So I'd want to show that, for example, UT over RT would come up with some kind of ratio, right? And in my second given, I was given stuff about VT and ST, which I've highlighted in green. So I basically want to show that UT over RT is equal to that second ratio. And since I went large to small, I want to make sure I'm consistent. So I'm going to say I want to show that VT over ST is equal to UT over RT. How do I do that? I'm going to do some algebra. So all I have to do here is do what we were doing in our first lesson, right? Manipulate your cross products. I'm basically going to take these and divide them to create our ratios, right? So if I divide, I'm going to get UT over RT is equal to 5 over 3. And if you don't remember how I did that, let me just do this on the side. 3UT is equal to 5RT. And remember, if my goal is to get RT underneath UT, I want to first divide by RT first. And that'll move that RT out of the way. And then I don't want 3UT over RT, so I'm going to go ahead and also divide by 3 to get rid of that 3. And that's how I'm left with UT over RT equals 5 over 3. So I just did some division. I can do the exact same thing to get VT over ST, right? So VT over ST, if I did a little work on the side or in my head, I would also get 5 over 3. Okay, and that was just with my division property. Then I want to state that they are proportional, so I'm going to go ahead and substitute. Since they're both equal to 5 over 3, what I care about is getting this statement right here on the right. So I want to say UT over RT is equal to VT over ST, and that was from substitution. So I have two proportional sides, and sorry, that's this property. All right, so now I've got two pairs of proportional sides, and finally, I need to say that the included angles are congruent, and that's what we said earlier. We've got our vertical angle, so I can say angle STR is congruent to angle VTU because of vertical angles, right? And then finally, we can say that the two triangles UVT and RST are similar by SAS. And again, make sure the angles are included. So see how I highlighted these two sides? See how the angle is stuck between the two highlighted sides? That's how we know it's an included angle. So what's new here is really just the proportions, so steps 1 through 3. So look for that. Unless you're using angle, then we're just using congruence. I'll come back to class with questions. See you guys later. Actually, we're not quite done because I had added in this extra example after I made that video a few years back. So let's go ahead and finish off example 3, and then we'll actually be done. So before we start, one thing I completely forgot to do when I made these copies was to mark in CB and DE as parallel. So let's pretend those were already there, and then let's get started. So when you read through the directions, hopefully you see we have two tasks. We want to explain why the triangles are similar, And then after that, we want to go ahead and find the length of AE. So two different things, make sure you actually do both of those tasks. And if you think about it, we can't actually find the length of AE without knowing the triangles are similar first. And that's because, remember, all of the sides are proportional only if the triangles are similar. So let's start with proving the triangles similar first. So now it wouldn't hurt to actually look at, well, where are the triangles in the diagram? So hopefully you guys all see we've got one triangle here, triangle ABC, and then a second triangle here, triangle AED. So those are the two triangles we want to work with, and remember we're proving similar. So similar means we're looking at angle-angle similarity, side-angle-side similarity, or side-side-side similarity. So we want to think, well, what does this diagram even tell us? Well, you might realize, wait, Ms. Huang, you highlighted something twice. And what actually overlaps in both of these triangles is this angle right up here, angle A. So this is what we'll call a reflexive angle. So we have a reflexive angle which tells us one pair of angles is congruent, so we already know for sure SSS is out of the picture, right? So that's kind of nice. So then we just have angle-angle or SAS left to work with. And then you might remember, wait a minute, parallel lines? Parallel lines always tell us information about angle measures. So that's what we want to work with next. So let's think about, where are my congruent angles? So if we highlight just those parallel sides for just a moment, and then pick a transversal that connects the two. So I'll go ahead and connect AE, but if you want, you can connect AD. And we want to see what shape comes out of that. Well, we see this F shape, right? It looks like this upside down F. And remember, that's a way for us to remember, wait, we've got corresponding congruent angles because those lines are parallel, and now we've got angle-angle similarity. So I'm going to go ahead and jot down my proof. You can, of course, write your explanation out in words if you like, but feel free to write a formal proof to help you figure out your work. All right, and there we go. So there is my first part. I've just proven the triangles are similar. So now that they're similar, it follows that all of my corresponding sides and angles are proportional, right? So then we want to go back and look at our whole diagram and see what sides are we working with. So I'll see right here, we've got a side length 10 for CB. So then you want to ask yourself, okay, what corresponds to CB? Well, CB and DE are both in the same position, right? They're the bottom of those two triangles. So there's one proportion we can work with. So we can say, all right, CB over DE gives us a similarity ratio, which should then equal the similarity ratio of another pair of sides. So we want to find AE. So AE is this entire right-hand side. So what corresponds to AE? Well, that's got to be AB. And then since I did small triangle on top, big triangle on the bottom, I want to go ahead and be consistent. And I'm going to put AB on top over AE. And there I have my proportion. So all I have to do is substitute in my numbers. So 10 over 32 equals 12 over AE. Now be careful, this is the entire length AE. Some people think it's just BE, but remember we're comparing an entire side to an entire side, so that AE is the entire side of that larger triangle. So we are solving for AE here. Okay? It's up to you if you want to simplify now. I like to make my fractions smaller so they're easier to work with. So I'm going to go ahead and simplify this fraction. So dividing it by 2, I'm going to get 5 and 16. And then let's go ahead and do our cross products, right? So I'm going to go ahead and cross multiply and see what we get. All right, so I just went ahead and finished my work. Remember, it's perfectly fine to get improper fractions as your answer. If you want to round that, you can go ahead and round that. Sorry, not round that. If you want to convert that into a decimal, go ahead and do that, but just don't round. And here we wouldn't need to because it does turn into 38.4 as a exact decimal. But there we go. That's the rest of example 3. We want to have both parts, both the proof, which is the explanation, as well as the answer for the length of AE. Okay, so now we are officially done with 8.2, and this was section 7.3 in our textbook. If you have any questions, definitely let me know. Thanks for listening.